But let me open the floor to questions. And while people in the room and people online are considering those questions, I'll take the chair's prerogative, and I'll start with a question for Rishi, in fact. So Rishi, you're using this masking process to understand the patterns in the data, which might make you, are you effectively imputing these missing values then in order to model? If so, and you might tell me I'm wrong about that, but if so, what about the problem that Ian described, which is that we don't often know what the reference is? So our sepsis 3 outcome, we're all agreed, is not a very good reference standard for the true diagnosis of sepsis. We don't believe often when those patients have received a sepsis 3 outcome that they truly had sepsis clinically. Could you use the same masking process to predict outcomes as input variables?
Yeah, so the imputation is also one of the clinical tasks I've seen in the papers, but we are not imputing the data. So the data we are masking is the really observed data. And by masking them, we just remove them, and then we tell the model to learn like what was the real value using the other values. Yeah, and for sepsis, I'm yet to test the model on sepsis because there were not really very popular clinical benchmarks available for sepsis, so I used mortality prediction. But for the clinical benchmarks, we have like ICD codes that directly tells us the label sepsis, so we don't need to use like specific consensus of sepsis. The score to decide the label. So that simplifies the complexity.
It may do, but Ian and I might tell you that those ICD-10 codes are probably not very good either. So we can predict ICD-10 codes, but whether we're truly predicting sepsis.
So one thing I was thinking to use the Phoenix criteria with.
So Phoenix is a new criteria. Children, yeah. Ian, do you have any thoughts?
Hershey, you're using neural networks.
Yeah.
Okay. In our work, we're using a extreme gradient boost ensemble around a random forest. They seem to also be able to deal pretty well with irregular time series, right? But they do impute, right? But you're not imputing. I feel that's really the essential difference. But I was just interested to see whether you can compare your model, those RNNs and CNNs, with a extreme GD boost type model. Have you done that? That'd be, I think, interesting to see.
Yeah. So we
do you mind if I repeat the question? Because will people be able to hear online? Yeah. So I think the essence of Ian's question is to compare the method that, and I'm going to get stuck in the weeds here, the method that Ian's team's been using for model building, which was a extreme gradient boost ensemble, and also it appeared to handle these irregular series well, and how that might have compared with Rishi's emit-based system.
Yeah, so that's a good question. So actually, I haven't done that, and the reason for that is the baselines which I use, GRU and GRUDK and all the argument baselines, we have quite extensively tested against these gradient boosting methods. So it's kind of commonly accepted that these models are better than the gradient boosting. So with that reference, we didn't test it.
Okay.
Yeah.
You'll be even do it.
Yeah, that's true.
Any questions from the room? Dai?
Using a sepsis diagnosis, or if other sepsis models use that. I was curious about previous sepsis diagnosis as a predictor.
Okay. The sepsis 3 criteria things. So the sepsis 3 criteria, okay, they're applied as the label. Now, I think you're asking, okay, what about if patients that had a diagnosis of sepsis in the look-back period? Is that what you're asking? In other words, has the patient had a sepsis diagnosis at some stage during the admission? Did we feed that into the model? I think, is that the question you're asking? Yeah, that's right. In other words, previous admissions? Or, yeah, okay. No, we deliberately did not want to confuse the model by including a sepsis-coded diagnosis from previous admissions. Okay, so each prediction that the model makes is only specific to that admission. Okay, and also that the time window is a look back of no more than about 72 hours, because we didn't want to go back further and further in time, because then, again, that's introducing more noise into the model. And besides, we want to sort of look at a more accurate model closer to the actual event. Now, the more you go back into a look-back period, then the more stuff you're dealing with, and that just can sometimes make the model actually noisier as well. So, in answer to your question, the previous diagnoses of sepsis on previous admissions were not included, were not inputted.
Thank you, Ian.
So my question is like, how did you account for the uncertainty in the predictions? Like, so did you like consider the confidence bars for making predictions for that?
Yeah, I didn't actually put confidence intervals in the stats, but yes, they are there. And I think, obviously it depends on the sample size, doesn't it? Okay, so the prospective study, we had smaller samples, so okay, the uncertainty was wider. But on the previous data set where we had about 250,000 admissions, the confidence intervals were pretty small.
And there's still pretty good sized data sets on there, as you say, 240,000 in the retrospective derivation, if you like, set, and 60,000 in the prospective evaluation, that 3 months evaluation, which compares favorably with those PhysioNet and Mimic 3 data sets, doesn't it? Yeah. And so it can be reasonably confident in those predictions. So I'd just like to thank both of you. Ian, you know well that I'm very much hoping that we can replicate some of the work you've been doing in adults, in children, and really make a difference to the prediction of sepsis in children. The challenge for us is that, you were saying that your threshold is 12 or 15%. I was very impressed. If there's a number needed to treat of 4, for each sepsis case that you identify, I would say for us in pediatrics, where the pre-test probability of sepsis is, in ED at least, somewhere of the order of 5 in 1,000. I think if we can get to the stage where 1 in 10, 1 in 20 of these alerts is actually sepsis, 1 in 5, 1 in 10 certainly is actually sepsis, then we'll have achieved an enormous amount. And I'm hoping that I'll be working alongside Rishi and we'll be getting him some data in children too. He's continuing to work with the ICU group as well at Queensland Children's Hospital. But I really think we've got scope to do some really important work here in Queensland. I particularly like the way you're already thinking about the clinical implementation and how we take account of workflows and design and user interfaces. And I think those are the critical elements that haven't always been considered in other machine learning implementations.
So agree. So I think the people are moving towards the foundation paradigm, like a ChatGPT kind of model where one model can do many kind of tasks. That's what I've seen in AI, like AI research. We're just trying to create time series models, like a foundation where, so one model throughout, for everything.
One model to rule them all.
Yes. Yeah.
Okay, well, I think that probably is our time for today. Thank you for attending. Thanks to those of you online. Thanks again to Professor Ian Scott and Rishi Patel for their fantastic talks. And please complete the survey. Thank you.